Let's solve another problem from the Philippine Math Olympiad. Let x, y, z be three real numbers such that yxz form a harmonic sequence and 3xy, 5yz, 7zx form a geometric sequence. The numerical value of y over z plus z over y can be expressed in the form p over q, where p and q are relatively prime positive integers. What is p plus q? Alright, so this problem clearly requires the use of algebraic manipulation method. This means that we need to come up with equations that we will manipulate in order to solve for the numerical value of y over z plus z over y. Now, let's take advantage of the given sequences here. The sequence yxz is a harmonic sequence. What do we know about harmonic sequence? If we take the reciprocals of the terms of a harmonic sequence, the resulting sequence is an arithmetic sequence. So let's take the reciprocals of these terms. So we have the given harmonic sequence with terms yxz. If we take the reciprocals, we get 1 over y, 1 over x, 1 over z. This sequence is now an arithmetic sequence. And take note, an arithmetic sequence has a common difference. So if we subtract the first term from the second term, and then the second term from the third term, the result is the same. So we can say that 1 over x minus 1 over y is equal to 1 over z minus 1 over x. This simplifies to 2 over x. If we combine like terms, this is equal to 1 over y plus 1 over z. If we combine the fractions in the right hand side, we obtain z plus y over yz. So this is now our first equation. However, we don't know yet how to utilize this equation, but I'm sure this will be helpful later on. Now, let's take the second given, the geometric sequence 3xy, 5yz, 7zx. So the geometric sequence is 3xy, 5yz, 7zx. Now, what do we know about geometric sequence? Take note, a geometric sequence has a common ratio. In other words, second term divided by the first term is equal to the third term divided by the second term. So we can create the equation 5yz divided by 3xy equals 7zx divided by 5yz. Now, if we clean this up and solve the equation in terms of x squared, after cancellation of common factors, we get yz equals 21 over 25x squared. So this is now our second equation. What do you notice about the equations we've come up so far? The first equation contains z plus y or y plus z and yz. The second equation contains yz. So this actually gives us a hint that we might want to write this expression into another form that contains z plus y and yz. Okay, because If we can write this into another form containing those expressions, then we can easily use these equations right here. Now let's do that. So we have y over z plus z over y. If we take the common denominator yz, the numerator is y squared plus z squared. Now we have an expression that's equivalent to the given, but it only contains yz. However, I can write the numerator into y plus z squared minus 2yz. Now if you expand this and then subtract 2yz, you will see that it's just equivalent to y squared plus z squared. Now if we split this up, we get y plus z squared divided by yz minus 2. So I have cancelled the common factors in the second fraction. Okay, so if you look at our second equation here highlighted in red, yz equals 21 over 25 x squared. So let's replace yz here with 21 over 25 x squared and see what happens. So if we do that, we get 25 over 21 times y plus z squared over x squared minus 2. We can further write this into 25 over 21 times y plus z over x all squared minus 2. Okay, so if only we know the value of y plus z over x, then we are done, right? Now, how can we come up with an equation containing y plus z over x so that we can find the value of this? Let's go back to our two equations on top. Now let's try multiplying these equations. So I'll place 2 over x and 21 over 25x squared in one side and the other 2 in the other side so that I can cancel x and yz. So we have 2 over x times 21 over 25 x squared equals z plus y or y plus z over yz times yz. So now I can cancel common factors. I can also cancel x here, so there is one remaining x here. If we simplify this, we get 42 over 25x equals y plus z. And from here, it's very clear that the value of y plus z divided by x is equal to 42 over 25. Okay, so now let's replace this with 42 over 25. So that we have 25 over 21 times the square of 42 over 25 and then minus 2. I will not expand this because I can write this into 25 over 21 times 42 over 25 times 42 over 25 minus 2 and cancel common factors. 25, 42 divided by 21 is 2. So if we simplify this, we get 84 over 25 minus 2. 2 is the same as 50 divided by 25. So we have 34 over 25. Notice that this is already in lowest terms. In other words, the numerator and denominator are already relatively prime. So now the value of P is 34, the value of Q is 25. And we can easily get now the value of P plus Q. So P plus Q is equal to 34 plus 25 equals 59. And this is our final answer.